calling C++ from Python? What would be the quickest way to construct a Python binding to a C or C++ library? I am using Windows if this matters.
You should have a look at boost.python. Here is a short introduction taken from their website. The Boost Python library is a framework for interfacing Python and C++. It allows you to quickly and seamlessly expose C++ classes, functions and objects to Python, and vice versa, using no special tools, just your C++ compiler. It is designed to wrap C++ interfaces non-intrusively, so that you should not have to change the C++ code at all in order to wrap it, making boost.python ideal for exposing third-party libraries to Python. The library's use of advanced metaprogramming techniques simplifies its syntax for users, so that wrapping code takes on the look of a kind of declarative interface definition language, IDLE.
C-Types module is part of the standard library, and therefore is more stable and widely available than Swig, which always tended to give me problems. With C-Types, you need to satisfy any compiled time dependency on Python, and your binding will work on any Python that has C-Types, not just the one it was compiled against. Suppose you have a simple C++ example class you want to talk to in a file called foo.cpp. Since C-Types can only talk to C functions, you need to provide those declaring them as extern C. Next you have to compile this to a shared library. And finally you have to write your Python wrapper, for example in foowrapper.py. Once you have that, you can call it like.
There is also pbind 11, which is like a lightweight version of boost.python and compatible with all modern C++ compilers. This URL
The quickest way to do this is using Swig. Example from Swig tutorial. Interface file. Building a Python module on Unix. Usage. Note that you have to have Python dev. Also in some systems Python header files will be in /user/include/python 2.7 based on the way you have installed it. From the tutorial. Swig is a fairly complete C++ compiler with support for nearly every language feature. This includes preprocessing, pointers, classes, inheritance, and even C++ templates. Swig can also be used to package structures and classes into proxy classes in the target language, exposing the underlying functionality in a very natural manner.
If you want to see more, please consider subscribing.